Okay, so far we've dealt with quadratic graphs and their parabolas, and we've shifted them, looked at them in vertex form. We're going to continue with vertex form, but also add on standard form. So our essential question is, how can you change the vertex form of a quadratic function to standard form? So first, let's identify a few graphs and identify if they're quadratic functions or not based on their graph. So the first one is x plus 1, which as we look at that is just a linear graph. So then we would state that this one is no. And then we look at the next one, x squared plus 2x minus 6. And as we'll see that gives us that parabola shape that we are used to. So we would say that is a yes. And then the next one are 2 to the power of x. And you see that green, it does have a curve to it, but it does not go back up like a parabola, so that one would be a no. And let's turn the... Now, next one is 2x squared minus 3. You can see there we get a nice parabola shape on that one. So that would be a yes. And then our next one is negative parentheses x minus 3 squared plus 7. This time we get a concave down parabola. So that one also is a yes. And our last one is the square root of x. So we do get a little bit of curve, but it is now kind of opening to the side and does not have that other half to it as well. So this one would be no. How can you determine whether a function is a quadratic or not by looking at its graph? So as we saw on the previous, that any parabola or quadratic has kind of this U shape to it, whether it's vertical concave up or vertical concave down. Okay, so some of us claim this U shape. It's technically what we call a parabola, but that similar shape there. And then how can you tell if a function is a quadratic function by looking at the equation? So that one we will discuss in class. So be ready to answer that question. So identifying a quadratic function in standard form. So the standard form of a quadratic function is f of x or y equals ax squared plus bx plus c. So we've seen that before. We've called it standard form. We just haven't attached it to a graph. Then our axis of symmetry, when it's in this form, is found by going x equals negative b over 2a. So taking our b and a value, substituting that in, and that gives us the x value of our axis of symmetry. And then our vertex is taking the negative b over 2a, which is our x value. And then whatever that value is, you plug it into your function, and then that gives you a y value. And you'll see how that works later. So for each function, find the axis of symmetry and the vertex. So let's start with number 3 here. So we said axis of symmetry is x equals negative b, which in this case b is 12, over 2a, and a is a negative 3. So we get negative 12 over negative 6, which is 2. Now we want to substitute that back in so we can get our y value for our vertex. So we get negative 3 times 2 squared plus 12 times 2 minus 5. 2 squared is 4 times negative 3 is a negative 12. 12 times 2 is 24 minus 5. Negative 12 plus 24 is 12 minus 5 is 7. So we would say that our axis of symmetry is x equals 2, and our vertex is 2, 7. So our second one here, so we get x equals negative b, so it's negative negative 2, all over 2a. So two negatives make a positive, so that becomes 2 over 4, which is 1/2. So substituting that in, so f of 1/2 equals 2 1/2 squared minus 2 times 1/2 plus 8. So then that gives us 2 times 1/4 minus 1 plus 8, and we get 1/2 plus 7, because negative 1 plus 8 is going to be a plus 7. So that gives us 7.5, or 15/2. So then we'd say our axis for this one is x equals 1/2, and our vertex is going to be 1/2 and 15/2. So explain why the function represented by the equation y equals ax squared plus bx plus c is quadratic only when a does not equal 0. Okay, again, this one be ready to give your explanation in class. All right, so I want you to determine whether each function represented by the equation is quadratic, and then have your reason. Again, we'll go over this one in class. All right, so rewriting to change from vertex form to quadratic form. And so as you see here, we're going to take it from y equals a x minus h squared plus k, which is our vertex form, to y equals ax squared plus bx plus c, to standard form. So given the function y equals 4x minus 6 squared plus 3, we're going to expand out that x minus 6. So remember, that means x minus 6 times x minus 6. So we'll distribute, and we get x squared minus 6x minus 6x plus 36. Combine your like terms, and we get x squared minus 12x plus 36. Remember, that was just part of the whole. So we have 4 times that x squared minus 12x plus 36, and then plus that 3 at the end. So now we need to distribute. So we get 4x squared minus 48x plus 144, and then plus that 3. Now we want to simplify, so just combine like terms, and we get y equals 4x squared minus 48x plus 147. And so that's going from our vertex form to standard form now. All right, your turn here. So pause and work through this one. And when you're all said and done, you should get y equals negative 3x squared minus 12x minus 13. If you have any questions, ask me when we get back into class. All right, so the next is we want to be able to write equations given a table of values. So easiest is to start in vertex form, and then we can transfer it into standard form. So as we look at our table, we want to identify our vertex. So remember, a parabola is something that's either going to go like this, and we get that turning point, and that's our vertex, or it's going to go like this. But on each side, we have mirrored values. So we go 9 and 9, 1 and 1, and then 0. So then our vertex is going to be negative 3, 0. And then vertex form is going to be y equals a x minus h, which is the negative 3, squared plus k, which is 0. So simplify that a little bit. We get y equals a x plus 3 squared. And then we want to figure out our a, so we use any point in the table. I'm going to use 0, 9. And so I get 9 equals a 0 plus 3 squared. So 9 equals 9a, divide by 9, and a equals 1. So that means our equation is y equals a, which is 1, x plus 3 squared. Now from there, they asked us to convert it to standard. So then what I'm going to do is I'm going to distribute all this out. So we get x plus 3 times x plus 3. So you get x squared plus 3x plus 3x plus 9. So you get y equals x squared plus 6x plus 9. There's no terms outside that to distribute in or add, so then that would be our standard form. So again, let's write from vertex form to standard form. So we have our mirrored values again. So our vertex is going to be at negative 2, negative 3. So our vertex form is y equals a x minus h, which is a negative 2, squared, plus k, which is a negative 3. So simplifying that, you get y equals a x plus 2 squared minus 3. Again, pick a value. This time I'm going to pick 0 and 13. So we get 13 equals a 0 plus 2 squared minus 3. If I add that 3 over, we get 16 equals a 2 squared. 2 squared is 4. Divide by 4, and a equals 4. So then we get y equals 4x plus 2 squared minus 3. Now we need to get this in the standard form. So x plus 2 times x plus 2. And you get x squared plus 2x plus 2x plus 4. And then combine like terms, you get x squared plus 4x plus 4. But now this time it is multiplied by 4 and then subtracted 3. So distributing that 4 in, you get 4x squared plus 16x plus 16 minus 3. So then our standard form is y equals 4x squared plus 16x, and then 16 minus 3 is 13. All right, your turn. Make sure you identify your vertex, put it in vertex form, find your a, and then find your standard form from there. And once you work this completely out, you should get y equals 6x squared minus 24x plus 29. Now, similar deal, but now we're doing it from a graph, so we need to identify our graph as far as the vertex. So then we're going to go with that as our vertex. So our vertex is at 0, 25. So then our vertex form is going to be y equals a x minus h, which is 0, squared plus k, which is 25. So simplify that down, and we get y equals ax squared plus 25. Pick a point, and we go with 1, 9 here. So we get 9 equals a times 1 squared plus 25. So subtracting that 25, we get negative 16 equals a, because 1 squared is 1, 1 times a is just a. So then substituting that value in, you get y equals negative 16 x squared plus 25. And then since this one has no set of parentheses, we don't have that x minus h squared in there. There's nothing to distribute. So then that one happens to be in vertex form and standard form. So you're done. All right, your turn on this one. And once you're all set and done with this one, you should get f of x equals negative x squared plus 2x minus 1. All right, questions to be ready to have answers for is, what is the standard form of the quadratic function? And then how many points are needed to write a quadratic function in vertex form given the table of values? So be ready with your answers on those two there. And then you have your quizzes. And our essential question, what can you do to change the vertex form of a quadratic function to standard form? Be ready for this. Go back and look at the steps that we used. And your assignment, 6.3, page 247, 1 through 9, all, 12 through 20 even, and then 24.